Okay, guys, so we're going to be starting the heart today. So this video is going to be up for you guys to look at if you have any questions, concerns, need an additional resource to kind of go through. So the way that we're going to do the heart is you guys are going to be filling out a kind of like a PowerPoint as we go with some blanks and stuff. And I'm going to take you guys through that in a second. That's going to be broken up into 2 days. So the first day today is going to focus on just the chambers of the heart and the valves. So just the heart itself. In day 2, we're going to focus on the veins and arteries and blood vessels surrounding it. So today we're just focusing on the heart itself, just the valves and the chambers. If you've taken medical emergencies before, this might be super, super simple for you because I know you cover the heart in that class. But if you haven't, that's no big deal. That's why you're here to watch the video. So what I'm going to do is just for now, just kind of go through the different chambers and like the direction of blood and where it flows, because there's really going to be 2 big things that we're always concerned with. Where is blood going? So from what to where? And then is that blood oxygenated or deoxygenated? I'm going to be using red for oxygenated blood and blue for deoxygenated blood. But as we've talked about many, many times in class, and as you guys know, I'm kind of a fanatic about it, blood is never, ever, ever, at any point ever blue, right? It's always red. I'm using blue as like an example, but just know that your blood, whether it's deoxygenated or oxygenated, it doesn't matter how much oxygen's in it, it's always, always red. So we're going to kind of go through the chambers and the valves and talk about where the blood kind of comes in and out. And then I'll jump over to the PowerPoint and do the first slide kind of with you guys to show you how it's supposed to work. And then I'll be posting a video for day 2 that's going to talk a little bit more in detail about the veins and the arteries and things of that nature. So the entire loop of your heart, it's a big cycle. So you could kind of start wherever you wanted to. It doesn't matter what chamber you start with. It doesn't matter what valve you start with or anything like that. Technically, it's a big cycle, so it doesn't really matter. I'm usually going to start in this upper chamber right here. But you don't have to start there, just so you know. So for whatever reason you like to start on the other side of the heart, you absolutely can. One other thing before I start, probably one of the most confusing things for students about the heart is that it's flip-flopped. So normally your left would be here, right? This would be my left, and then this would be my right. However, whenever you view the heart, you view it as that person's heart. So it's actually reversed. So probably hands down, the reason that students get things wrong with the heart is they knew that it was like the atrium or the ventricle and all that kind of stuff. The problem is they got confused as to what's left and right. So in your heart, whenever you're covering a heart diagram, it's always reversed. So even though this is the left-hand side of the paper, this is going to be considered the right side of the heart. And even though this is the right-hand side of the paper, this is going to be considered the left side of the heart. So I know that's kind of confusing. Just always remember it's backwards. What I'll do sometimes is I'll be like, okay, it's the chamber on the right side. And I'll be like, oh, it's actually on my left side because that's where my left hand is. And I'll reverse the direction. So it's always easiest to do it that way. So we're going to start here in the top chamber. Now your top 2 chambers, this guy here and this guy here, are called your atriums. And atriums receive blood, they take blood in. So blood's first going to come in, and again, we're not covering arteries and veins today, but this is what's called your vena cava. We're going to cover that in more detail next class. So it's going to come in there, and this is going to be its first stop. So you'll notice I'm doing it in blue. So this is deoxygenated blood. So this blood has just come from around my body. It's blood that's been picked up from all my muscles and my brain and all that kind of stuff. So I've used up all the oxygen in it. So it's very, very low in oxygen at this particular point in time. So it's going to arrive, and again, this is the right side of my heart, and it's an atrium. So this would be considered your right. I'm going to zoom in just a little bit so I can actually write. This is going to be considered your right atrium. So this is where blood is first going to enter the heart. Okay, this is where blood is received. Kind of think of it as like the lobby. Okay, now it's going to then move down. So this is a valve. So valves, there's 4 of them in your heart, and they are between the chambers and between the major blood vessels. And valves kind of do 2 big things for us. It's in your PowerPoint, I already gave you this definition, but valves do 2 big things. One is they prevent backflow. So we always want blood, again, the direction it's flowing is really, really important. We don't want our blood to mix. If our deoxygenated blood mixes with our oxygenated, that makes it way less efficient, right? Think of if you're going down a one-way street and all it takes is that one person that's like, oh, I missed the address. And if they tried to drive backwards down that one-way street, that would not go very well, right? It's the same thing with your blood. We want it, just like our action potentials that we talked about with nervous system, we always want it going one direction. So valves make sure it goes only one direction, because when this chamber fills up, and again, this is your right side, so it's the right, and that's the bottom one, so this is your right ventricle. When your right ventricle fills up, it's going to close this valve. Once this valve closes, it means blood can't go back into our atrium, again, ensuring it can only go in one direction. So valves prevent backflow, prevent blood from going the wrong way, and they also help to build up pressure. If you guys have ever used like a super soaker or any sort of water gun, right? Usually what you have to do to make it go far is you got to use that handle to like pump up and build pressure, and then you pull the trigger and it shoots a bunch of water, right? If you didn't pump that handle, when you pulled the trigger, water would just kind of dribble out because there's no pressure. Your heart kind of works the same way. When this valve closes, right, now blood can't go backwards. When this chamber squeezes and gets smaller, it's going to build up pressure and force the blood this way with a lot of force. And you might think, why do I need a lot of force for my blood? Like it's just going to flow. Certain places in your body, yeah, it would flow no problem, right? It would go down to your legs, no issue. It would go to your arms, probably no problem. But think about your head, right? Like regardless, unless you're laying down, if you are sitting or standing, that blood has to go against gravity. And obviously I want to make sure it gets to my brain. So that blood, depending on how tall you are, right, might have to flow a couple feet upwards against gravity. So you do need a certain amount of pressure. So again, valves help to prevent backflow, and they help to build up pressure. So we have our blood that came into our right atrium, this top chamber here, and then it went down into my right ventricle. Now the chamber, or I'm sorry, the valve that it went through, this valve right here, I'm going to label it number 3 because again, it's still in an area of deoxygenated blood, is called your tricuspid valve. And the reason it's called that is, as we can assume based on the word tri, is it's got 3 flaps. Now I know this isn't the best image in the world, because it's a 2D picture, obviously, right? But the idea is that it actually has a 3rd flap. So all 3 of those flaps close once the right ventricle fills with blood. So we have blood comes into our right atrium, goes through our tricuspid valve into our right ventricle. And then now the ventricles are like not only are they the bottom chambers, they're the chambers that push blood. They have you can see here, this one has way more muscle around it than our atrium, right? Our atrium right here has almost no muscle, whereas our ventricle has more muscle around it. Gives it more force. It can push blood more. So when this thing contracts, and that's what I'm showing with these arrows, right? The vessel's going to contract. I'm sorry, the ventricle is going to contract. It's going to push blood up, and it's going to go out to the rest of our body. It's going to go to our lungs. So that's what these vessels are going to go to. And we're going to talk about those next class. But it's going to go through these arteries to our lungs. But the idea is that this valve is going to close once they do that, again, to prevent backflow and to build pressure. And this valve right here, which I'm labeling as number 4, this valve is called your right semilunar valve. Now it's called the right semilunar valve, and I'll zoom out a little bit so I can actually write that somewhere. So it's called your right semilunar valve. And it's called obviously it's called your right, because it's on the right side of our heart, right? Remember, because the heart is reversed. And it's called semilunar because this image isn't the best, but the actual valve, the pieces of it, like if we were doing a dissection, you would actually see they almost look like little crescent moons. So lunar is moon. So they almost look like little crescent moon shaped components. So those 2 things kind of block it. And again, that's the whole goal, is the valve's going to help us prevent backflow. So it's going to prevent blood from flowing backwards into my ventricle. And it's going to help build pressure so I can push that blood to my lungs. So this is all the deoxygenated side. The whole right side of your heart, you'll notice, is all blue, right? It's all deoxygenated. So it's going to come into my right atrium. It's going to go through my tricuspid valve into my right ventricle. The right ventricle is going to push it through my right semilunar valve, and then it's going to go to my lungs. Okay, so this is all deoxygenated. So the goal here is we collected blood from around our body that had already had the oxygen taken out of it. It's already used. And now we want to send it to our lungs to get more oxygen. Okay, so that's all the right side. So now we'll look at the left side of the heart, which is all of the oxygenated stuff. So this one is a little tricky to start because where the blood's coming in is not quite as clear. So again, this is the left side of our heart. Even though it's on the right-hand side in the diagram, remember your heart is reversed. So this is the left-hand side, and I'm going to do it in red to show that it's oxygenated. Remember though, blood is always red. It is never ever blue. So the blood we just said is going to go to our lungs. Now it's got to come back from our lungs. So it goes to our lungs, it picks up some oxygen. So now I need to get it to the rest of my body. So it's going to come in here. So this is going to be from one lung, and then it's going to come in on this side from another lung, because you have two, right? You have a right and a left lung. Again, we're not going to talk about the vessels for now. We're going to worry about that next class. It's going to come into this chamber right here, which I'll label number 1 because it's the first part that's oxygenated. And this is your, again, it's the left side of the heart, even though it's on the right-hand side of the picture. So this is your left atrium. It's the chamber on the top. That's how we know it's the atrium. And it's on the left-hand side of the heart. That's how we know it's the left. So your left atrium. So this receives oxygenated blood. So at this point, it's rich with oxygen. We want to get it to all of my vital organs and brain and muscles and all that kind of stuff so they can use that oxygen and survive. So now, just like before, right, when we were in our right atrium, we went down to a ventricle, which is what we're going to do, but we need to go through a valve first. So we're going to go through a valve into our left ventricle. And we went through this valve here, which is, I'll label number 3 on this side. And this this valve is called your mitral or mitral valve. Okay. Again, the exact same function as our tricuspid. It's between the atrium and the ventricle. And it's going to, again, it's a valve, so it has the same 2 functions. It's going to help to prevent backflow. So once this left ventricle fills up with blood, it's going to prevent blood from going back into our atrium. Remember, the heart is a one-way street. And then the other thing it's going to do is help to build up pressure so that my ventricle can force blood up, which is what it's going to need to do. You'll notice the left ventricle has lots of muscle because your left ventricle is going to push blood all around your body. So this is where it gets a little tricky, just because a lot of diagrams, this one included, the way your heart's kind of designed, the other valves and stuff, like it kind of tucks behind the other side of your heart. So it's a little tricky to see, but it's the same concept. So we're in the left ventricle as before. So just like when we were on the other side, we're in our ventricle. Now we got to go out to somewhere else. So on the right-hand side of our heart, we sent blood to our lungs to go get oxygen. Here, we already have oxygen, so we're not going to go back to the lungs. We're going to go to all the other organs in our body. So we're going to go around the body, basically. We're not going to name off any one particular place. So to do that, we have to go out the left ventricle through a valve, right? And that's this valve right here, which is number 4. And again, the heart, in a sense, is kind of easy to name all the things because they're all related. So this valve kind of has 2 names. You can call it your left semilunar valve, right? Because it's the exact same thing as the right, it's just on the left-hand side. Or some people, and I like to call it the aortic valve because it leads to your aorta. That's how I remember it. You can call it either one. You can either call it left semilunar or you can call it aortic. I prefer aortic just because, again, it lets me know, okay, it goes to the aorta. It kind of helps me remember the order of things, but you don't have to do it that way at all. So it's going to go out my left semilunar valve, and then it's going to go out your aorta, which is this big guy right here, which we'll talk about more next class. And that's where it's going to go all over your body. So that's when it's going to go up to your brain, out to your arms, down to your legs, all your abdominal organs, all that kind of stuff. It's going to go out to the rest of your body. So that was the goal for today, is just to talk about the chambers and the valves. We're going to talk about the arteries and veins in more detail next class, but just to kind of quickly summarize, again, we're going to come in your right atrium. So we bring in deoxygenated blood that's already used up all its oxygen. It's going to go through our tricuspid valve into our right ventricle. And then that right ventricle is going to push it to our lungs after it goes through our right semilunar valve. It goes to your lungs, picks up some oxygen. It's going to come back to your heart. It's going to come back in and arrive in the left atrium. It's going to go through the mitral or mitral valve into the left ventricle. And then that left ventricle is going to push it up into your aorta, where it's going to go to the rest of your body. And it's going to do that by pushing it through the left semilunar valve or the aortic valve. So those are the major chambers and valves. So you have like 8 terms you really need to know right now. The 4 chambers, left and right atrium, left and right ventricle, and then the 4 valves, the tricuspid, the right semilunar, the mitral, and the left semilunar. Okay, so 8 vocab terms that we should kind of start to try to work with. So that's the diagram, and that's the like info portion. So what I'm going to do now is I'm going to jump to the PowerPoint you guys have and kind of show you what I want you guys to do for that. So give me 1 second to bring that up. Okay, so you have your diagram of the heart here. So we're going to kind of work through all of these. So again, we're just doing day 1. My goal is I don't want to overwhelm you guys with like a million different slides and all this other kind of stuff to do. So we are just doing slides 3 through 11 today. So the first thing you're going to do is the next slide, slide 3, has a couple definitions that we're going to fill in. And then slides 4 through 7 are going to cover the chambers. And then 8 through 11 are going to cover the valves. So for the missing definitions, those are very easy. We just talked about those in our PowerPoint, or I'm sorry, in the diagram. Remember, our atriums are what receive blood. And our ventricles are what basically they push out blood. Our atriums are always the top chambers, and our ventricles are always the bottom chambers. And the valve, I kind of already gave that to you guys, so I wouldn't have to write it out. Has 2 major functions. It keeps pushing blood in one direction to prevent backflow, right? We want it going one way and one way only. And it helps to build up pressure so that we can pump blood with enough force. So I'm going to do this chamber with you guys. So you kind of see how the chambers are supposed to work. So on every single slide, there are 3 things that you have to do. You have to tell me right here which chamber it is. Let me do it in blue though, because we're deoxygenated. So you have to tell me what chamber is it. You have to tell me where it's pumping blood to and from. And then you got to tell me, is this blood oxygenated or deoxygenated? So based on this diagram, what I'm looking at here, again, this is on the left side of my diagram, but the heart is flip-flopped. So this is actually the right side of the heart. So we know it's right. I already gave that to you. And it's the top chamber. So this is the right atrium. Okay, it's going to pump blood from, so it receives it from the rest of my body. And if you wanted to get specific about it, it receives it from the vena cava, that's the vein. And it's going to send it to the major area below it here that I just circled, which is going to be your right ventricle. And then I just have to decide, okay, does this blood have oxygen or is it deoxygenated? And I know it's deoxygenated. So I would you can either highlight deoxygenated. If I were you, I would just erase the oxygenated bullet point. It's up to you how you would like to do it. And that's all you have to do for that one. So I now know the chamber. I know where the blood's coming to and from. And I know that it's deoxygenated. You'll also see that on every single slide here. I know when we were in school, you guys really liked using those diagrams that we would spend a day like doing definitions and we would color code them and all that kind of stuff. And you had that for the rest of the unit. I can't require you guys to do those anymore because it's a hard copy. And I know a lot of you have access to the printer and I know a lot of you talked about how you would like to print those and you are more than welcome to. I've attached it on Classroom. You can print it out single-sided and cut them apart and tape them together just like we've always done. And you are more than welcome to use that diagram. If you can, I think that would be really, really helpful, but you don't have to. It's not required. If you are doing that diagram, I've given you the number for every single thing on that diagram. So if you've printed out that diagram and you have it in front of you, or if you want to do it in the future, it is number 3 on that diagram is the right atrium. So you're going to do the same thing for the next 3 chambers. So again, all you're telling me is which chamber is it? Where is it pumping blood to and from? And you're going to tell me, is that blood oxygenated or deoxygenated? Okay. And then the valves, you're going to do the same thing. So we're looking at our tricuspid valve here. All you have to do here is tell me we're going to send blood, but it's a valve between what 2 chambers or what 2 things. Okay. So that is all you're doing for today is you are filling out slides 3 through 11. So this is slide 3, the definitions that we just did. You're going to go through the 4 chambers. And then you're going to go through the 4 valves. So this right here, the left semilunar or aortic valve, that is the last valve you're doing. Then you'll see it's day 2. We're not going to do day 2 yet. So this is the last slide we're stopping on. And once you've done that, there is an exit slip on Classroom. It's 4 points. It's going to give you, like, it's graded in the sense that it's going to tell you how many you got right and wrong. But as long as you complete it, it's a full score. I just want to give you guys some feedback so you can see, okay, I got 2 out of 4. I'm really good on chambers. I have no idea what the valves are yet, that sort of thing. So it's going to give you a grade, but just know that you're going to get a full 100 on Classroom, or I'm sorry, in PowerSchool, regardless of what you get on the assignment, okay? So you can watch this video over as many times as you want. We're doing slides 3 through 11 in the PowerPoint today. You're filling them in. And then there's the exit slip on Classroom. If you guys have questions, concerns, things that don't make sense, whatever, any questions at all, remember you can either email me or send me a remind text, or similar to when we had that like review day for the immune system, I'm going to post a Google form that you can fill out. If you have any question at all, you can ask a question on that thing and I'll shoot you back an email with the answer. Okay. So have a great day, guys. And I will send out another video and stuff for day 2. So again, as always, send me reminds, send me emails if you have any questions, but have a good one, guys.